We're going to look at the profiling toolpath. Again, I have my simple 2D drawing stock and tools installed. I'm going to go to the Visual Mills MOPS, go to Create, and pull down the 2.5D axis and look for profiling. I want to select the curves as regions. Again, this works better than the flat areas for 2.5D. And I'm going to pick two of these. And again, we can see those. We're going to select a tool. And I'm going to pick that same 1/2" ball nose so that we can see the large cuts it makes in the simulation. Feeds and speeds are already set. Again, 360 would be a real cut speed here. I'm slowing this down simply because I want it to show in the simulation. Clearance plane, I want the part max plus a distance to clear any clamps or screws that I'm using. Cut parameters. For tolerance, this is how close to the line do you want me to get. And so I always set this out at 4 decimal places, and I set my stock at 0. I want to not leave any extra stock. What this is, you'll see this a lot in some tool pathing, especially in 3D, is they leave enough stock so that you can come in and sand. So I always put this to 0 and let the tool go ahead and cut to it. Cut direction, climb versus conventional mill. You should understand this. Most of the time in profiling, we're cutting a trench, so it's on both sides, and so it really doesn't matter, and we leave it at mixed. If I'm cutting a profile in airspace so that I'm only cutting on one side of the tool, I almost always want to use climb milling because it gives a better finish. Cut start side, do I want it on the left side or the right side of the line? This is where, when we use before, we would set preferences to show the cut direction. This is how we indicate this. So I happen to know that the right side will work for this, or use outside or inside for closed curves. Now, these are closed curves because I use them, I grouped them in Rhino, so I can be safe here instead of using right or left to use the outside, because that's what I want here, of this curve. Or if I wanted to cut a line on the inside of these, I could use inside. I can also step over control. We're only going to be using one trench through this, so we don't need to deal with those right now. Cut levels. Again, this is how deep I'm going to cut. My geometry is at the top of my material. I want to go 600 thousandths deep. I'm going to do my roughing cut. In this case, I'm just going to go ahead and use the full depth as roughing, not have a finishing depth. And then under roughing depth down here, this is how deep it's going to cut per pass. Now, if I want to do this all at one shot, I can go as deep as 500 thousandths, since that's the diameter of my tool. But I want to slow the simulation down a little bit, so I'm actually going to go 200 thousandths so that it makes 3 passes. Cutting level ordering. Depth first means it's going to cut the full depth of this entire line all the way around before moving on to the next. If I use level first, it'll take forever in that it cuts everything to the first level, and that would be 200 thousandths. Then it comes back and cuts everything at 400 thousandths, and then comes back and cuts everything at 600 thousandths. So I always use depth first here. Entry and exits is indicating how the tool moves in. So again, you can play around with this and see what works. None is always the safest, and you can simulate this and see how it's going to enter and possibly cut in the wrong direction. Also, with profiling, a long path 3D entry is easier on the tool, and I have found that it works fairly well. Advanced cutting parameters. Most of these we can just leave as is. One of the big ones that you may use for some profiling, if I wanted to cut these all the way out, in other words, I wanted to leave like a block of material, I can use bridges. And bridges will leave little tabs, if you will. Bridges are also called tabs, to hold the part in place. If I don't use these, and if I'm cutting these all the way out, when I get done, the last cut, the part will be free to move and it'll hit the cutter, damage possibly the machine, and most definitely the part. So if I'm cutting with a profile all the way out, I want to use bridges. Sorting, again, that tells the order that we're going to be cutting in, and typically minimum distance sort is the way to go if you have more than one or two things. With one or two, it's not going to make that big a difference. So we're going to generate that, and here our little blue lines appear. And I want to simulate this, so I'm going to go to Simulate, and with 2D Axis Profiling highlighted, I'm going to run the simulation mode, and here you can see the part cutting. And now if I go in and zoom in on this, one thing you'll notice is I didn't have, since this is a 1/2 inch tool, I didn't have a 1/2 inch between my line that I drew. Scan in a little bit more. Here's my original line and the edge of the piece. So when this is cutting along the outside edge, it's actually cutting outside the stock, so they're not going to have any waste material over here. This is fine as long as I didn't put screws along this edge or some clamping mechanism. If I put a clamping block or a stop block over here, probably the likelihood is the cutter would have hit it. So the other thing to notice here is our little highlighted original line. This cuts to the outside of that. Remember, we could cut inside or outside. So it cuts to the outside of that, leaving the original block. Remember, engraving cuts along it, leaving a smaller inside space.